hello from some. Know that there are people from. Yeah, this will happen. You see, uh, some people will start from
Sir,
other side. Okay. Anyway,
record. I have started the recording, sir.
okay. Rishabh Chaudhary, are you there? I saw he was the first person to get in. Rishabh, can you hear me? I'd like to find out that whether they're hearing me or not.
Normally, what I do, sir, I say one. Yeah, he's replied to the conversation.
Yeah, that's why I'm saying that I'm trying to find out. I called Rishabh Chaudhary,
He
but
said
I
yes.
do not
No, on the
whether
chat. He has said on chat, yes, sir. You're very clear.
oh, okay, okay. Thank you, thank you, thank you. Well,
Hello.
today, in fact, I'm sure that you have gone through several aspects. Today, I'm going to talk to you on some building systems as it used to be in the ancient days and what is today, and what are the transformations that we have gone through, and what kind of, particularly the structural systems that were associated with it. Many times, knowingly or unknowingly, things were being done. And how do we explain those in terms of mechanics today when we look into from the perspective of structural mechanics? How do we explain those phenomena that what they had adopted? And we try to see in today's perspective that how this can be built in. So as you know that the basic needs of any civilization that have happened is the first thing, of course, we need food, we need clothing, and the third important thing is the shelter. And so people have tried to find out the avenues, the ways by which shelter can be created. And from the time when people did not have anything, people started finding out find out the places where they can put themselves in and can save from different, kind of natural calamity, different kinds of wild animals, and several such things to protect themselves. They try to find out some kind of a protection wherein they can put them in. And that's how the concept firstly of the shelter came in. Now, if you really look into the different aspects on it, or the areas or the aspects on which the shelter creation has affected, is of course the climatic conditions. Depending on different kinds of climates, people have tried to find out protect themselves from this. Could it be extreme heat? Could it be kind of nature's fury in terms of extreme wind, or again different kinds of if you have a very cold, so different kinds of climatic conditions have have forced people to look for some kind of protective place where they can save themselves. Second thing is that whenever you try to think of creating something, of course you need to have an appropriate material, and with that material you'll have to create the protective place which we call eventually as I said. So over a period of time, in fact, from the early days, as you have seen, that we had Stone Age, we had Iron Age, and people have tried to evolve materials. And over a period of time, different kinds of materials have evolved, and different kinds of materials have been used to create a different shelter. And still, this is happening. This is an area where I think the continuous the research activities are happening, and people are trying to develop different kinds of materials which are being used for creating the shelters. And you must have seen in the modern days also, people are trying to make use of different kinds of materials to form different kinds of configurations in the building systems. And thirdly, which is very important, is the adoption of the technology. As you will find, maybe in earlier days when people had used their creation. Some, well, we do not know what kind of technology was with them, what kind of experience they had, and mostly, possibly based on their experience, they tried to come up with something which you can explain through mechanics today when you look back. But importantly, the technology has evolved over a period of time. Different kinds of technologies have come in to help creation of different kinds of shelters. At certain point of time when the usage of the uh, lift was not there, the vertical transportation, vertical movement was difficult. So people had to restrict themselves up to certain level, up to which they can, climb by using stairs. But when the introduction of the lift had happened, when the vertical transportation system came in, people could think of building system in which they can climb vertically, right, without climbing through the stairs. So that's an introduction of the technology which has helped people to think otherwise. So likewise, there are several such technologies which have come up, which have helped the construction sector to extent in terms of machineries, in terms of different kinds of equipments. And of course, today we are talking of different kinds of technologies for the maintenance of the systems. So, the technology has helped to a large extent to grow this particular sector from the ancient days to today. So, these factors are very important, and these are required to be looked into. And in fact, if you look into that, today even we are worried about the climatic conditions, because you cannot have a control on the nature. You cannot, have a control on the creation of the cyclonic weather. You cannot have the control on earthquake. So these are natural phenomena which are going to happen. So all we need to see is that how do we create a system which can be resistant against the fury of such climatic conditions. And that's where, and I think from the very beginning, people have tried to do that, either through the experience or through the involvement of the technology, the involvement of the materials, tried to use different kinds of materials, tried to understand that which material works better for that kind of a climatic system. And accordingly, they have tried to adopt that. And that is what is the crux of the whole thing that you will see. Well, as we are saying that shelter protects people from weather, shield them against wild animals and insects. And naturally, after the day's work, they need to take rest, spend some time, sleep over place. And so you need a place which is gives you a comfort. So, the earlier days, as I said, the people try to look for places where they can protect themselves from such kind of things. And earlier caves are the examples where you find that people are trying to protect themselves inside the cave. And there are several examples of some kind of caves where, particularly in the mountainous range, where people use these as shelter. So this is the possibly the earliest form of shelters that we can look into is in the form of caves. Right? Uh, Also, as people started seeing, and different kinds of materials they started exploring for, like the stones, they possibly, as you have seen in the mountainous range, the caves were the places where people could protect themselves, keep themselves in. Possibly the man-made shelter first time that came up with was with some kind of stones or rocks that are available naturally. And then, with the help of some plants, some tree branches, they could create something which gives, again, some kind of a protective system for them. So, they tried to create these, they possibly brought in branches in a manner which can be placed so that it remains in position. That's also a kind of a thing that came up with their experience and all. So, this is the kind of a thing which they could create out of the stones and the trees that are available. So this could be earliest form of the shelters that were created by the human being. This is an important thing that you look into, is that these are the stones. They are placed stacked one after another, created some kind of closed shelters where people could get in. It's kind of a cave, but it's again a man-made system. Uh, but interesting part that I wanted to show it to you over here is that you look at this particular place. You see, here there is an opening, and across the opening they have kept a stone which is spanning across this gap. So from one end to the other, see, this is one stone which is holding the stones above, and that's very important. This is again there's a kind of a mechanics that's very important to look in. But from where they got the concept, say possibly they have understood from the experience that unless they do this, the stones above this cannot be kept in position, right? So let me tell you, today if you see most of the houses that where you have openings for doors and windows, across that we try to provide member. And the material that we use for different kinds of structures will be different, and most of the time that you see is with concrete and brick masonry. So the walls are created with the bricks and the cement mortar. We call that as a brick masonry. Now, when we create or try to create an opening in the brick wall, uh, and across the opening, if you do not put some kind of a member, you cannot put the masonry onto top of the opening. So what we try to do is that we try to create a concrete element we normally call as a lintel, which acts as a beam. And over that, we can create masonry, brick masonry wall, which can hold that the beam can hold the weight of the wall above it, and thereby you can create the opening. So you see, it's a similar kind of a thing that has been done over here. Here, this particular stone actually acting as this lintel today. So and the load which is coming from the stone above, uh, it can hold it. In fact, if you have seen because earlier days when the concrete was not there, most of the systems that were built were either with the stone which was available naturally, or when people started, trying to develop bricks, the burnt clay bricks out of the earth or the mud, people started using that. And if you look into some of the structures, particularly the structures which were created in earlier days, when again concrete was not available, people used to use brick masonry to a large system and also stone masonry. And both stone and brick masonry, they could be in the form of a dry system, or it could be connected with the mortar. Now, here I am showing you another system where actually you will find many places where you do not have a flat lintel of this kind. You have a curved arch across the opening. And if you have visited our old building here, you must have seen the just above the windows or the openings, you have arch of this kind. The reason being, the arches, the load when it comes onto top of that above arch, you can build again the masonry system with the brick. So when this is loaded, the load gets transmitted in the form of thrust. So and with the back or the reaction of it, it can hold the whole brick system together. So even if you do not have a flat member, the bricks can be kept in position by giving this kind of a form. Actually, this is what I just wanted to explain over here. You see, by bricks are all individual units, and these individual units can be placed together, connect with the mortar, and give the form of this. And because of this thrust and the reactive forces, these bricks can be kept in position. They don't get dislodged. So this is the kind of a technique that were adopted in earlier days when systems were created with the brick masonry. But what I wanted to show you over here is that the concept, that was prevalent at that point of time, which we could explain the concept of the mechanics, that how the gap, or the openings are to be bridged with the members. That kind of a bridging technique they knew. So that's what I wanted to emphasize on this particular slide. Now, three things on which we normally, in structural system, when we talk about three S's. We say the strength, stiffness, and the stability are the three important parameters on which the whole structural system hinges on. Strength in a sense that it should be able to hold the load which it is subjected to, so that the material is strong enough and it does not crumble, it does not fail. It should be able to, it's like this. Let's say you have a vertical member on which you have some system, and the load is applied on this. Now, this member should be able to hold the load, in an appropriate manner without failure. So the material is strong to hold this load above it, right? So we say it depends on different kinds of material. If you use brick masonry, it will have some carrying capacity. If you use concrete, it will have some carrying capacity. If you use steel as a member, it will have some carrying capacity. But the point is that whatever material you use, it has its capability. It has its stress, which we can call it as a permissible limiting stress for that material. So if you apply the load and if you try to calculate the stress at any point, if that actual stress that is getting developed is less than the permissible capacity of that material, then the system will be able to hold the load. So we say that this structure is strong. It means that it has the capability to hold that load without a failure. It can sustain that load within its stress capability. Second thing that we talk about is the stiffness. Let me just give you the example of this. That you have a member. Say I have taken two members. One is little thicker, another is thinner, and apply the similar kind of a load. So what we expect, the member which is thicker will undergo some kind of a deflection, but this deflection will be less than the deflection that this member will. The reason being that this member is stiffer than this, and this is what we mean by the stiffness. That if we have a stiffer member, it is expected that the deflection is going to be less. So depending on how much such deflection, when it is loaded, if this member undergoes deflection, then there is a possibility that the kind of stresses that will be generated, it may not be able to hold that. So, or if it undergoes, or even if the material can hold it, and if it deforms excessively, then it will not be able to, serve its purpose. Let's say this is a floor system, and if this floor deflects to a large extent, people will not be able to use it in an appropriate manner. So, we try to find out that what could be the limiting value of this deflection, so that accordingly we can decide that what should be the thickness or the depth that is needed for this member. And that's what we call in terms of stiffness. And third thing is the stability. Actually, these are the supporting system for this. Third thing is the stability. If you have a member, let's say it's a very long vertical member, which we normally call it as a column. If it is subjected to a load, there could be a limiting value where this member cannot remain vertical like this. It deflects in this particular form. And so that means at certain load, this vertical member is no longer stable. It may be strong. It may be, if you calculate the stress, level of stress could be well within the permissible limit of the material, right? So material can withstand that load. It is strong from the point of view of the calculation of the stresses, but the system is not like this. Or let's say in this you apply a lateral load. We get lateral load because of the application of wind or earthquake, and that lateral load will destabilize this system. So this is not a stable system. So you need to look for a system which can withstand vertical load, lateral load effectively, and does not deform excessively, does not deflect excessively. And that's why we need to make it a stable system. So, you need to satisfy all three criteria to give a stable system. And that's what we try to look for. And you see, if you look from this perspective, the earlier structures as God, in some places, there could be deficiency of certain things, but you will observe that first two parameters were satisfied to a large extent. They had kept their concern about the strength. They were concerned about the stiffness, and accordingly, the systems were developed by which this is, I mean, they could make it effective. So these are the requirements from the structural mechanics point of view. I just try to look into the systems that were developed in different ages, starts from the Indus Valley civilization, and let us look into some of the aspects that what kind of building system they had used, what kind of material they had used, what kind of technology they had adopted. I mean, whatever methodology they were aware of, they tried to make use of that, and created some shelters for themselves. Um, and as we see over a period of time, as the civilizations have progressed, different structural forms have come in terms of temple structures, different temple structures in different parts of the country, different region, in different form. Many a times is a place people had created as a place of worship for the god, and possibly it was symbol of the status for the kings who had ruled the places to create some structure. And many kings have tried to create structures which are, if you look into from the perspective of the architecture, if you look from the perspective of the external system from the point of usage, they had a grandeur, there's a grand structure. But when you try to look from the perspective of the structural aspects, that what was the concept with which it was built, how do you explain them from the perspective of the structure, that whether they could resist the load. In fact, if you see those creations of those days, still many structures are working okay with some amount of distresses, and those distresses, if they are taken care of, still they can function. And that's how we try to preserve these heritage structures to a large extent. And then how we have moved from the earlier era through Middle Ages to the early modern structures, the structures which were created during the Mughal period, Maratha period, Sikh period. And then, of course, the colonial structures, British colonial structures had a kind of a form, which I was trying to tell you in our old building system, which you see in the Hijli jail. And of course, now in the present day system, that what are the kinds of things that we are trying to create, how we are trying to safeguard the systems against the environmental loading, the weathering conditions and all. So we many a times you must have heard that we say that the structure or the building has to be earthquake resistant. That means we try to create a system which can resist the earthquake forces effectively, and the building does not undergo any distresses or collapse. That kind of a system we try to create. Okay. So let's just have a look at the kind of systems that were created during this Indus Valley civilization period. Of course, Harappa Mohenjo-daros are the examples that we keep talking about when we say the early Indus Valley civilization aspects. And what we observed there, that the system, they had a very nice planning. The whole arrangement was in the form of a grid, as we do. You have regular patterns. The systems were created. We find that they had a very nice drainage systems, and they say that the irrigation system, the drainage system was unique in those periods of time. Also, what has been observed is that in those days they had made extensive use of the bricks, and these are mostly the mud bricks, either in unburnt form or in a burnt form. But interesting part is that if you look into the size of it, it had a proportion of this, that 4:2:1. 1 is the thickness, 4 is length, 2 is the width. In fact, I don't know whether you are aware of the sizes of the bricks that we use today in the present day. Normally, we call it as 10 inches, 5 inches, 3 inches, means 250, 75, and 125. So 250, 125, 75 millimeter are the sizes. Length, its width, its thickness. So if you look into in the proportion from in that sense, if you take thickness as unit, then you get about 1.6, 1.7 times as the width, and about 3.3 times as the length. So that's the kind of a proportion that we try to use as a conventional bricks that we use today. But the bricks that were used during those days, we find that these are the kinds of proportions that they had. But uh, you see that they had come up with some kind of a form which they thought it would be appropriate to use it and construct. Now, there are houses which were not only confined to only a single story, they tried to build in multiple stories. It has been observed 2, 3 stories buildings were there. And thereby, in most of the places, in those kind of earlier days houses, you will find that the roof covering are with different kinds of materials which are not flat as such. But in Harappa Mohenjo-daro, it has been observed that they had the concept of having the floors horizontal, and that's how they could build the upper stories as well. And the horizon, when you try to create horizontal surface, naturally you need to understand the mechanism of holding the load and transferring the load in an appropriate manner. Because when you have the walls on the four sides and keeping opening inside, and you are trying to cover that up, you will have to hold, or you will have to put some material which can hold that roofing material, and the load can be transferred to the extreme sides of the walls. And that's the kind of a concept. See, today we can create that with the concrete, we can span larger gaps and then we can create it. But in those days, in fact, they had made use of the timber or the woods that are available from the trees, and using maybe the tree plank, the tree trunks they had used to span across the walls, and then onto top of some leaves, and then the mud onto top of that, and create a horizontal flat surface. So that kind of concept they have built, and that's how you can explain that how the whole thing was built in those days. So this is some kind of a form that you see where extensive use of bricks have been shown, clay bricks, and in fact, as I said, that they had used both unburnt clay bricks and the burnt clay bricks. Unburnt clay bricks in a sense that you form out of mud and then get it dried in the sun and use it directly. But eventually, what they had possibly had encountered is that during rain and all, they get exposed to water, and it gives problem. So eventually they try to use burnt clay brick, because it has been observed the places where it gets exposed to the water. In those places they have used burnt clay bricks, and in the same building itself, the part which is not going to be exposed to that extent to water, they had used the unburnt clay bricks. So they had made use of the combinations of the burnt and the unburnt clay bricks. That's interesting. So in fact, possibly they learned through the experience, through the over a period of time, that yes, how these things should be made use of. Uh, if you look into that, the cities, the houses in those places, they were planned. As I said, that it had a grid pattern, running across east to west and north to south kind of a thing. The buildings in the areas were surrounded by the walls again as a protective measure, and this wall used to be thick, substantially thick. In fact, this is what is the observation that we have. If you look into the ancient day structure, you will find that the walling system that they have used is substantially thick. The reason being that they tried to transfer the load in terms of gravity to the soil below, and again the system should be stable against lateral load. When these are subjected to wind or earthquake, it should not collapse. So the thickness of the walls were substantially large. In fact, in many places, I'll show you in some temple structures and all where they are built with the stones is a substantially taller system. There, they have used the wall thicknesses of the order of 3 to 5 meters. So you can think of that, I mean, those days possibly the scarcity of land was not there, so they could make use of the huge space for creating such structures, and they could afford to go for such thicker systems where they could transfer the load very easily, both in terms of the gravity load as well as the lateral
Sir,
load.
what were the streets made of?
What?
Sir, what were the streets made of? I mean, were they made of bricks?
Uh, there, there were various systems in Indus Valley civilization. It was made of bricks, mud clay bricks, either in a unburnt form or in the burnt.
Okay, sir.
Okay. Uh, Also, as I said, that they had a very nice drainage systems in those days. So you see the kind of system that they have created over here. This picture shows very clearly that so this is a single-storied building or a room that they have created where the roof surface is a flat one, and so what they could do is they can use some timber or the tree material spanning across this wall over which they have used again the mud things for creating this horizontal surface. So this concept was available with them, and they could create this. Uh, the interesting part of this that the material, as I was saying, that is made of mud and mud bricks. Uh, then some part of it they had used the kiln fired bricks, and some places they had the unburnt bricks, and they had used the buildings mostly on the roadside. That was a part of the planning or the architecture. You see, it's a kind of a fortification that they have done, and inside they have created this. So as you enter into a courtyard, and people used to have different units separately, like the bathroom areas or the kitchen areas. They never used to be connected with the same system as we do today. So they used to have different units which are placed in around this, and then you have a large courtyard, and this courtyard used to be used for different kinds of purposes to get the exposure from the sun. And also, since they could create different stories, single-story, double-story building, maybe 2 or 3 story building. So they made use of a stair, which is a narrow stair which is placed outside the building through which people could climb and go up. So and it's a solid kind of a system that they had created, not a staircase that we create today, where you can see the steps can be folded and you can climb up with a relatively lesser space. So, but in those days, possibly they did not have that concept. That's why they had used a solid system over which they had steps and through which they could climb up. So, and also, you must have noticed one aspect today when we try to create a building system, the level, as you enter in the ground floor, the floor level is kept higher than the ground level. You must have noted that normally we try to keep that floor level about 2 feet higher than the ground level. The reason being that, in case there is a kind of a flooding due to water, rain and all, so the floor level does not get affected. Even if the water gets accumulated on the ground up to certain depth, at least you are on the safer location on the floor side. So that's the concept they also had. They tried to keep the floor level higher because of the rain, the area is to get flooded, and naturally they could protect themselves if they keep it at a higher level. So they had the concept. Possibly it was not specified as a floor level, plinth level of that kind, but they used to keep the usage space above the ground level, and thereby create a system which is safe. So looking at the safety aspects of it, looking from their experiences as they're encountering, uh, they are trying to make use of this. In fact, just to give you an example, even in the present days, somewhere in 2000. 13, 12, 13, we had a huge cloud burst in the area of Leh. And in the Leh region, actually, they used to use the mud bricks, mud bricks, the clay bricks, which were unburnt. So they used to create those bricks in this form, sun dried, and use them in forming the building. And that's how they had created most of the buildings in the Leh region. But during that cloud burst time, when huge amount of rain had happened, then there was inflow of water inside that region. So all the houses got damaged, in fact, because of this cloud burst. And eventually, that's when people realized that yes, they will have to use different material, and that's a very recent phenomenon. In fact, so people have learned from the experiences that when things did not work, they tried to think otherwise and create things, and that's how things have evolved over a period of time. The building material that I was talking about, that mostly it was, see, these are the sun-dried brick, the mud brick, and these are the burnt bricks, burnt clay bricks that we use. Okay. And the bricks were of mostly equal size. And as I said, the staircases were with the solid, and roofs were flat and made of wood. This is made, they had made use of the wood as a material. So you see, most of the material that they use was with the clay or the wood that is available in the nature, which was naturally available, and they could make use of that for their usage. Uh, what we could see is that they had a planning concept. Today we talk about the planning aspect to a large extent, that for each and everything you need to plan in an appropriate manner so that you can create the system effectively. That you are going for a town planning or a city planning, or even a small area, if you are trying to develop, you need to plan it. You need to understand how things will come up, how will be the drainage system, how will be the road transportation system, and so on and so forth. So they also had a good planning concept. In fact, as I said, that the streets were put in a grid form, and alongside the streets, they had created the buildings. They thought about the drainage system so that the water can be channelized, taken to a safer place away from these. The wastewater that gets generated, how to take care of those wastewater. So sanitation system was prevalent at those kind of time. So they had a good planning concept which they had used in creation of these houses. Uh, so if we move towards the more intense civilization that was happening, if you look into some of the temple structures, because these are the good examples of the kinds of building systems that were created. And as I said that, most of the time the places were created for the idol worship. And that gave rise to the concept of the temples towards the end of the Vedic period. And we have seen that different kinds of temple structures were created. Started from, as we have given the example of the caves where people could stay safely. From that, those days of cave structures, people have come to the present day structure. So likewise, even the temples, people, and then gradually people tried to create out of the mud, using mud as a material. There are temples which are out of mud and thatched roofs, and then subsequently, of course, people have created temple structures out of the stones, out of the brick masonry, and of course today you make use of the modern material. So far as the usage of the material, if you look into over a period of time, you will find that different kinds of systems have evolved. Rock cut caves are very well known into the area of in the Maharashtra region. You have seen the Ajanta Ellora caves, where the structures were created cutting through the stones. This is the Ajanta structure that you see. It's a cave. The kind of structures that they were created, again, these are out of the rock cut systems made out of the stones. And you see the supporting systems, again, the concept. They have these supports at intervals, which we call as pillars or the columns. And over these pillars, they have a member which is running, see, from one end to the other, which is, we call that as a beam. And above that, you can keep a material to hold it. So that's the kind of a concept that they have. Possibly, they are not integrally connected as we try to do it today. And so what happens is you will find that there are structures which were created out of this cave systems. Where again you can explain, we can look into from the mechanics perspective that these are vertical or the pillar systems which are connected with the beams, and over the beams again there are structures. And you see this kind of systems that were created, as we say, is a form of an arch, so that you can transfer the load above this in the form of a thrust and not in the form of a bending as we need for the horizontal member. So they didn't have that concept of creating that kind of a member unless they get a piece of stone which can breeze across the member, right? And that's the reason this vaulting system was adopted to carry the load further onto the wall. Well, the temple architecture, if you look into the primarily the Hindu temples that were created the 16th to 16th, 6th to 16th century, they demonstrate the kind of system that was prevalent in those days. And we see different kinds of structure from south to east to north, and in different places, these kind of structures were created. And here you see that this is structure in the southern region in Mahabalipuram, in the coast, where they had created the structure out of the stone. The whole structure was made out of the stone, and in the stone, two kind of systems were prevalent. One where the stones, different sizes of the stones were placed, stacked together, and had a mechanism to hold them in position. But they never used in binding material. As you see today, that when you try to create a masonry system, either with stone or brick, what you try to do is that you connect them together with a mortar, so that you can create the whole structural system. Okay, so if we use mortar to bind these elements together, then we call that as a masonry system. But many a time, the structures were formed without providing any binder material. The stones were stacked side by side, and that gave the form of the structure. Those kind of structural system we call it the dry masonry system. That means the stones are not really bonded together using any mortar. So they are basically dry masonry system. Okay, so many structures you will find which were with the dry masonry. And these stone blocks, in fact, placed side by side, but they were interconnected. In fact, I will show you that they were interconnected together, so that they don't get displaced when they are subjected to the load. Right? So and give some solid mass to transfer the load. So you get two systems. One is called as the dry masonry system, where we do not use any binding material between the blocks or the elements like bricks, or another system where we use binder material and create the masonry structural system. So in earlier days, many temple structures which were created, they were with the dry masonry system, and they are made out of the stones or stone blocks. And also it is interesting to note that how such stone blocks were placed, to create this structural form, because they did not at those days they did not have the usage of the cranes or such kind of things, but still they could make use of methodology by which they could place the stone blocks one after another to create the structural forms. One of the finest example of this rock cut cave structure is this Kailasnath temple at Indora, where they started. They have created this cutting the stone blocks from the top. A rectangular domain. They were cut from the sides, and then gradually they could create this form. So, again, as you can see that as it is going up, it is tapering down. That also has a concept. From mechanics point of view, you can explain this because, towards the base, you need a larger size for transferring the load. As you go up, naturally, your requirement comes down, both from the strength point of view as well as the stiffness point of view, and also the stability point of view. So, possibly they did not have the concept of those clearly in those terms, but from the experience, from their learning, they could find that yes, this kind of systems are more effective, and that's how they had tried to create this kind of system. You see some examples of some grander structures like Meenakshi Temple or the Tanjore Temple. As you can see that have a larger base width as they have gone up from both sides, from the width direction as well as thickness direction. They have tapered it. As they have gone up, the sizes have gradually reduced. And the most interesting part of this were the carvings in the stones that they had. And again, across the openings, in many places, they had made use of the material that were available, either a stone spanning across the gap, or in fact, they had made use of some kind of iron, this cast iron members, which have been used in some of the structures, in some of the temples as well. So, if you really look into the kinds of forms from the southern side, if you come to the eastern part, if you look into the Odisha region, you have a large number of temples which were created in those days. And again, extensive use had been made using this stone as a material for creating this structural form. In fact, this is the temple which is Lingara's temple at Pune. This is the Jagannath temple at Puri. And these are the finest examples of the kinds of structural system that they had created using the stone masonry. And in fact, both the structures are made out of the dry stone masonry, where the stone systems were used to transfer the load, create this structural form. And thereby, there were no binding material or the mortar used to connect the stones together. Let me just show you the example of, I will come back to this structure. Just explain one aspect. Yeah, you see what they used is this a kind of stones. If you keep side by side without giving any connecting material between this, which we are calling as a dry masonry, they had used some kind of iron clamp in the form of U to connect these stones together, so that when they are subjected to loads, they do not get displaced. So this is the kind of system that they had used to hold the stone blocks together. And also, as I said, that the thickness of the walls were substantially large to transfer the gravity. But eventually, what has happened over a period of time, this since there are gaps between the stone blocks and all, there is a possibility of ingress of the moisture, and it has happened that moisture has gone through these gaps, and these iron clamps over a period of time got corroded. And when they got corroded, the volume of those iron clamps gets increased. It gives a pressure where it is inserted in, and the stones being brittle material, what happens is this starts cracking. And you imagine that if some crack starts initiating over here, it propagates in the stone. And if it gradually comes over here, this part of the stones eventually has no support below this, and it topples. So many places, in fact, this kind of distresses have happened into the structural system, which have been tried to be rectified using this. So what I was trying to tell you is that the kind of structural system that they had used in those places, and there are several such structures. You can see here again, you have the vertical members, and then across these to bridge the gap, they have used the material in the form of arts. Again, this is out of the stone. This entire thing that is out of the stone. So, you will find several such elegant structures that were created using stone as a material, and particularly the dry stone masonry as material. I think today we are very close to the time. I will continue on this. We will talk about some more forms as we have seen over a period of time, and also how the modern systems are being evolved. What are the concepts with which we are creating the modern day structure with the newly evolved material, the newly evolved technologies, and how we are making use of those in creating these systems. So I think let me stop over here. If someone has any question on this, whatever I just spoke about, then I can try to address those. Is there any question? I hope you are there. There's no response from you. Can someone speak?
Sir, the iron clamp system that is
Can you speak a bit louder? I'm unable to hear you.
sir, the iron clamps that were used to hold the stones together, that type of design is possible only in the tapered structures, right? Or the other way also.
No, you said that iron clamps that were provided, that possible only.
Only in the tapered structures where the height decrease from top to bottom.
Yeah, taper structure, no, not only for the taper. See, if you want to create the main purpose of providing those clamps were to, protect the stones to be in position, so that they don't move when they're subjected to the load sideways, and thereby create instability in the system. Okay. So basically, they wanted to keep the stones in position, even if they are subjected to, say, the wind load from the lateral side, the stones don't move, right? Yes. Now they had tapered it, but then as eventually have gone up, the thicknesses were reduced. But then uh, uh, even at the top level, the thicknesses are substantial in today's perspective. If you see, as I said, in the base level, the thickness could be of the order of about 4 to 5 meters. As they have gone up, maybe about 1 meter, 1.5 meters kind of a thickness still exists. So they could make use of those clamps in an appropriate manner. I don't know whether, I couldn't clearly get your question.
I was just asking that the iron clamp design uh, that was used to hold the stones together. Was that possible only in the type of architecture, where we had a triangular type design, or the opposite, or the rectangle architecture design we can also make, or only the rectangular type, like the temple that is in the photo.
Yeah, even if you go for a form which is of rectangular type, it's a different type. In that it was possible, but otherwise also it's possible to keep it, even if it is not in the form of a triangle. But typically we are showing it is a triangle, but in the upper level also there is substantial thickness. Okay.
Okay.
All right. So, as I'm told that we'll be meeting on Tuesday evening at 8 o'clock, and 8 to 9:30, that slot, on that I will try to complete the barrels part of it, and I will show you that how from this point we have come to this present systems of the structural form, taking care of the aspects of the strength, stiffness, and stability. Okay. Okay. Thank you very much then.
Thank you, sir.
Thank you, sir.
धन्यवाद.
Thank you, madam.
Yeah.
Thank you.
Thank you so much.
Thank you, sir. Thank you, ma'am.
Okay. Thank you. Thank you. Bye. Okay, Anuradha. See you
Yes.
then.